Good morning, boys and girls, and welcome back. Today we're going to do a quick overview of sequences and review of sequences from our pre-calculus days. We're going to talk about why sequences are important and how they're kind of used a little bit, or at least I'm going to start this lesson off today with, a way they kind of can be used. Let's pretend that you are a doctor and you are prescribing some medicine. Okay, so let's just play with this situation here. And let's say I give a patient a very small dose, but let's say we give them 1 milligram of medication, or one gram, or I don't know, whatever, one unit of medication. And this medication has a half-life of 12 hours. So after 12 hours, then there is half remaining. So after 12 hours, I've only got 0.5 of that unit of medication, grams, milligrams, whatever, left, right? And then what I tell them to do as a doctor is, hey, after every 12 hours, take another pill, take another dose. So after that, they take another dose, and so now they have 1.5, right, units of medication inside of them. And then now we got to wait another 12 hours. And again, half is going to go away. So after 12 hours, now they've got 0.75 units of medication in them, and now they need to take another dose. And so now they're up to 1.75. And now we're going to wait another 12 hours, and half is going to go away. And now now they have 0.875 units of medication left. And now again, we're going to have them take another dose. We're back at 1.875, and so on. And really, I'm going to quit drawing this out now, but we have the idea. But the question becomes, as a doctor, hey, now this is kind of important. Will this continue to grow and grow without bound? And they'll have an infinite amount of medicine, in them. That would not be good. That would probably kill somebody. Or will this amount of medicine converge on a value? Maybe let's say that's going to converge at 2. And, it goes to 2 and then drops to 1. And then goes to 2 and drops to 1. Like, that would be good. Then we know how much medicine they are going to have in their body on a constant, thing. So these are the kind of questions that we are going to answer, or we can't answer when we start dealing with sequences. Okay? Just so we know, again, a sequence is this, set of numbers. A sequence is just a bunch of numbers. I don't want to say in a row, but, a pattern of numbers, a list of numbers. Okay? We have kind of the two ends here, two sequences kind of going on, but, 0.5, 0.75, 0.875, would be one sequence we had. Plus, dot, dot, dot is one sequence we have going on. And then the other one is at the high end. 1, 1.5, 1.75, 1.875. That is a sequence at the other end. Okay? But a sequence is just a list of numbers. And so using these sequences, we could answer this question. All right, so back in pre-calculus, we talked about there's two different ways we can kind of describe a sequence. One is using the explicit formula, and the other one is using a recursive formula. We'll talk about the second one in a minute here, but starting with an explicit formula, let's kind of review a few things. A sub n stands for any term in my sequence. And then if we start adding numbers, a sub 1, a sub 2, a sub 3, a sub 1 refers to the first term of the sequence. A sub 2 refers to the second term, a sub 3 to the third term, and so forth, okay? And in an explicit formula, a sub n is saying if I want to find any term in my sequence, and then we generally have a formula that comes after it, 1 over n. Okay? Now, if I want to find any term in the sequence, I would just go ahead and plug in, 1 for the first term. I plug in 2 for the second term. So in this case, the first term would be 1 over 1, or 1. The second term would be 1 over 2, or 1/2. And the third term would be 1 over 3, or 1/3. I don't know why there was no reducing on these last two. That seems kind of silly that I wrote them twice. But anyway, so this explicit formula is describing the sequence 1 plus 1/2, not plus, I'll talk about that in a second. Should bring that up as well. But 1, and then 1/2, and 1/3, and 1/4, and 1/5, so on, right? Again, not plus signs. A sequence the difference, and we'll get into this more again tomorrow a little bit, but a sequence is just the list of terms. 1, 1/2, 1/3, 1/4, 1/5. If I start adding these things together, then that becomes a series. Okay, so that's the difference between a sequence and a series. A sequence is just the list of terms. A series is when we start adding these terms together. Okay. All right, so this explicit formula represents this sequence right here, we said, right? And just to tie this back into stuff we've done before, really, this sequence is also like the whole number outputs of the function 1 over x, just using the positive integers. You know, if I plug in just 1 into this function. So we can make a connection between sequences and functions, you know, and that way, again, when we do this stuff, you know, that we could use then equations and all that stuff in our real life application of things. Okay, and just one last real quick point here. With an explicit formula, I can find any term at any time. You know, we just wrote out the first 5 terms, say, of this sequence, but I said, what is the 100th term? If I said, hey, what is, you know, a sub 100, you would be like, oh, let me just plug in 100, and so that would be 1 over 100. So an explicit formula, you can find any term at any time, and that's what's kind of nice about it. Now let's talk about a recursive formula. All right, a recursive formula kind of looks like this. A to the n plus 1, which just means the next term, right? A to the n is the term, a to the n plus 1 would be the next term. And to find the next term, all we do is we take the term that came before, a to the n, and then we do something to it. So in this case, I'm going to add 3. With a recursive formula, you have to know the term before. Like, I can't just, if I didn't have this piece on the left here, I'm trying to cover it with my hand, but you guys can't see that. You know, but if I cover that up, if I get rid of that, if I just gave you this, I wouldn't be able to find any of the terms because I don't know a term to start from. Does that make sense? So with a recursive formula, we got to give you a piece to begin with. All right. So now, if I'm going to do this, if I want to write the terms of this formula out, I know the first term is 2. That is given to me. If I want to find the second term, then it would be 1 plus 1 is a sub 2. So I need the a sub 1, the first term, plus 3. So 2 plus 3 is 5. And then to find the next term, 3 would be 2 plus 1. So I need n is 2. So I need the second term plus 3 is 8. And so again, basically what we're saying is this recursive formula is saying you are going to add the next 3 to the previous term every time. A sub 4 would be 11. And so this would be the sequence 2, 5, 8, 11. The issue with a recursive formula generally may be a little bit easier to write. However, if I wanted the 100th term here, I would need the 99th. So I'd have to find every term up to that point, you know, and it takes a little bit of time to get there. So not quite as nice as an explicit sometimes. And then we're going to deal with both again. We're just kind of reviewing these two things. If I wanted to relate this sequence back to a function again, this might be represented by the function f of x equals, 3x minus 1. Those would be the outputs of that function. Okay, but we can generally find a function that would relate our sequences, and just these are different ways to express those same ideas, same terms. So today we're mainly playing around with these two equations, explicit formulas and recursive formulas, and just kind of getting used to this stuff again. So on our first problem today here, we are given an explicit formula because it's just a of n equals, and I want to write the first 4 terms. So to do this, I'm going to go find a of 1, a of 2, a of 3, and a of 4. So to find a of 1, I'm just going to plug in 1 for the n, and so I get 2 plus negative 1 to the first, which is 2 plus negative 1, which you get 1. To find a of 2, I'd plug in 2 for the n. So this is 2 plus negative 1 squared, which is 2 plus 1, which would equal 3. To find the third term, I'm going to plug in the 3. So this is 2 plus negative 1 to the third, which is negative 1. So again, I get back to 1. And then to find a to the fourth, I again raise negative 1 to an even power, so it's positive, so I get back to 3. And so probably by now you can see the pattern that is going to happen with this. Whenever I raise it to an odd, I get 1. Whenever I raise it to an even, I get 3. Odd, a 1, even, a 3. And so this sequence would look something kind of like that right there. Okay, so same idea now on this one. We want to write the first 4 terms. However, we're giving a recursive formula because I have a n plus 1. And this recursive formula actually works off of the previous two terms. A sub n is the term that comes before a sub n plus 1, and then a sub n minus 1 is the term that is before a sub n. And again, for me to find this, I actually need to be given those terms. If I just give you this, that is not enough information. They'll always give you those extra pieces that you need. So in this case, they told me a sub 1 equals 1, and a sub 0 also equals 1. Okay, so if I want to find the second term, a sub 2, that would be a sub 1 plus 1. And so that means n is 1. And there's my n value right here, right? So I need the first term, and then I need the first term minus 1, or a sub 0. So to find a sub 2, this would be the first term 1 plus a sub 0, which is also 1. So a sub 2 would be 2. If I wanted to find the third term, I would need a sub 2 plus a sub 1. So 2 plus 1. So the third term should be 3. To find the fourth term, it would be the term before it, the third term, plus the term before that, the second term. So this would be 5. And so my first 4 terms of this, or even 5 terms now, would be 1, 1, 2, 3, 5. Dot, 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 dot. 8, 8, then 13, and actually not thinking about it, heck, I should know this. This is actually a very famous sequence. Maybe bonus points if you bring me in the name, okay? Or at least a high five, definitely some kudos. We'll see if anybody figures it out. But 1, 1, 2, 3, 5, 8, 13, 21 is a famous sequence. Go look it up and learn about it. It's awesome. All right, for our next problem now, we're given a sequence, and we want to come up with the next 2 terms. So a lot of this stuff is going to be pattern stuff. You're going to be looking for patterns. And then also, because as I'm talking here, try to see if you can figure out what the next 2 terms would be. And then we're also going to want to write the recursive formula first, because that's a little bit easier, generally speaking, once you see the patterns. And then we're also going to want to write the explicit formula for this sequence, okay? In just different ways we can express this sequence. All right, so first let's go find those next 2 terms. And hopefully, as I was talking there, you probably noticed, hey, on the bottom, it looks like I'm just multiplying. The top is always 1. I'm just multiplying the bottom by 2 every time, right? So the next 2 terms would be 1 over 32 and 1 over 64. Or, leading us to our recursive formula, I am just taking each term and multiplying by 1/2, right? So for the recursive formula, I just now need to put that idea into a formula. To find my next term, an plus 1, I'm going to take the term before, a sub n, and I'm going to multiply that by 1/2. All right? So that would be our recursive formula. The only thing, if I do this, I need to tell people the first term. So in this case, I'm going to have to tell people that the first term was a sub 1. This is an important part of the recursive formula. You can't just give this part without that part right there. You need both pieces. Now this next part, writing the explicit formula, is a little bit trickier, and I think it definitely takes some practice. And we're going to be doing, a little bit of this as we move on. We're going to have a series or a sequence that we need to express using the explicit formula. So let's try to do this here. If I want my any term, a sub n, I know that, again, the top is always 1. So I'm going to start there. The top is always 1. And then the bottom is going to be, and I don't know if you can tell, but I had to pause and think about it for a second. But it looks like the bottom is always 2, right? Multiple of 2. So I'm going to need a 2 on the bottom to the, nth power. Okay? And if I just start here, then I want to kind of double check myself. And if I plug in 1, the first term, I'd get 1 over 2 to the first, or 1/2. That's not my first term. So I think I just need to adjust a little bit. And if I put 1 over 2 to the n minus 1, now if I plug in 1, that would give me 0, and 2 to the 0 power is 1. And so now this works. Okay, so now we found both the recursive and explicit formulas. remind me to do number 43 and 47 with the calculator tomorrow in class. See you later. Have a nice day.